Well, good day and welcome to episode 24 of The Driving Force, presented by the Louisiana Transportation Research Center. My name is Todd Blunt. I'm joined today by my friend, colleague, and co-host, Garrett Wee.
Good afternoon.
We're thrilled that you've chosen to join us as we highlight the people and projects driving change in Louisiana transportation. For nearly 40 years now, LTRC has merged the resources of state government and Louisiana universities to identify, develop, and implement new technology to enhance many critical aspects of the transportation system here in Louisiana and beyond. Central to our mandate as an organization is transportation research, as the name would suggest, and we are continuing today in a series highlighting various aspects of that research and introducing the talented and hardworking people who make it happen here every day. Our guests today on the show are Dr. Zhen Liu, who serves as LTRC's Concrete Research Manager, and Dr. Ricardo Hungria, one of our engineering interns in the Materials Research Group. This pair, along with their research partners, are making significant advances in their work. They've even been recognized nationally for the value they're adding not only to the state of Louisiana, but to the transportation community as a whole. We'll talk more about that a little bit later. We're looking forward to jumping into this conversation, learning more about several of their projects over the next few minutes. So we're going to step away briefly before we jump into our conversation with Zhen and Ricardo. Welcome back to The Driving Force. Today is episode 4 in our Research Highlights series, and we're excited to welcome a pair of LTRC's skilled and hardworking concrete researchers, Drs. Zhen Liu and Ricardo Hungria. Welcome to both of you.
Thank you. Welcome.
Thank you.
Well, let's start with each of you introducing yourselves and telling our listeners a little bit about your education and career backgrounds. Zhen, why don't you start us out?
Yes, my name is Zhen Liu. I graduated from LSU with a PhD in civil engineering in 2015. My PhD study was about developing green cementitious materials and their applications in civil engineering. One of the applications was using geopolymer for waste concrete recycling. So after graduating, I started to work in the private consulting firms. Okay. And in 2023, I joined LTRC as the concrete research manager.
Okay. 2023, so
Yeah.
You've been here about a couple years now.
Yeah.
Well, hello everyone. My name is Ricardo Hungria. I'm from Ecuador, where I obtained my degree in civil engineering, and I worked there for 10 years in the construction industry, in the Ecuadorian construction industry. I work in different projects from building construction to highway repair to the management of potable water and wastewater systems. Okay. And all this time, I had the privilege of working with my father, who mentored me in different aspects of engineering, and also showed me the importance of integrity and responsibility. I'm really thankful for him for that opportunity. Years later, I moved to Baton Rouge to pursue a master's in construction management. And I ended up staying and pursue also a PhD in engineering sciences. And for the past 2 years, I've been blessed working for the LA DOTD. So.
Awesome.
Yeah. Glad to have you all.
Oh, thank you. Thank you.
Before we jump too deep into our discussion about some specific projects, we'd love to hear why y'all enjoy doing concrete research. You mentioned your dad, but we'd ask you to dive a little bit deeper into that maybe. So how does the work y'all do each day positively impact the state of Louisiana and the transportation community as a whole?
I can start, when I was a student, in civil engineering, we got to know that concrete is one of the widely used construction materials. So that's why when I was thinking about my PhD research topics, so I was thinking if we could solve the problem related to concrete, then we should be able to solve a big portion of the problem related to construction projects.
Sure.
That's how I start my research in concrete. And then my advisor gave me, some ideas during that time. Okay, what we can do to improve the design or help the civil engineering community to develop some new technology, and also provide good quality.
Yeah.
That's the thing we were trying to do. We need new technology and also new good quality. So that's why we put something together, and eventually we put geopolymer for waste concrete recycling, and the application was pretty good. And then back to, after that, I really enjoyed doing research in concrete. It's pretty fun. And then we can see how our research could be used for our daily life.
Okay.
And then, in LTRC, in the past 2 years, starting from 2023, and I was involved in several projects. And then we did projects related to concrete durability, concrete testing, and then even internal curing. We try to see how we could use our knowledge and also the existing technology in the market to help the state to increase the service life and also, improve the efficiency, such kind of things. For the internal curing concrete, by using the internal curing, we can reduce the early cracks in the concrete.
Yeah.
By doing that, we can increase the service life a lot.
Sure.
And then we can also reduce the cost for the future maintenance. Because no cracks, then that means we don't need to maintain a lot, right? So that's pretty good. And we also talked to the Lafayette government. They like this kind of technology a lot.
Yeah.
So LTRC has been partnered with LCG a lot for several projects. And we had a tour in 2023 with people from headquarters, bridge design, and then material testing, construction, and also suppliers, producers. We show them how the internal curing could improve the service life for concrete, structures.
Yeah.
I think all the people enjoyed it.
Roads and bridges at last. That's a positive thing for the state.
Yes.
Ricardo, how about you?
Well, for me, every day is like a new adventure. Yeah. So our team works in different aspects of transportation engineering, from material characterization to mixing operations to analysis, design. So our work has the purpose of enhancing the service life of every transportation infrastructure. Yeah. So it's really nice to see how the work that we do in the lab translates into real world applications. Mm-hmm. And I think that serves the community because we make the roads better, longer lasting, more comfortable, and safer.
Yeah.
So I think that's how we, impact the world.
Yeah, I like that. Well said. Well, we're going to turn now to several of your recently completed and in-progress projects, and we're going to start, Zhen, with a project focused on evaluating something called the TFAST method for potential use here in the state. Zhen, tell us, what is this particular test designed to achieve, and what impact could it have on Louisiana's transportation system if it were implemented?
TFAST was first developed by the Federal Highway Tunnel Fairbank Lab. Because traditionally, all the aggregate evaluation was based on concrete specimens. We are using the engineering method or civil engineering method to solve the problems. But usually, people think they also learn from the previous experience. That's kind of accurate, and because it's based on the engineering method, engineering method are not like the strict science, I would put that way.
Yeah.
There's a difference, right? That's why they said, okay, we could try to focus on the real science behind the aggregate reaction. They try to find out, okay, what kind of a chemical reaction they have in the concrete.
Okay.
They try to totally, use the chemistry to solve the problem, to evaluate the aggregate, what kind of product they will have, and then what kind of a concentration they will build up. They need to determine what kind of threshold value they can use to determine this aggregate is reactive or not. Compared to the traditional method we were using, which usually cast concrete blocks or beam and measure the expansion. We don't care or don't look into the reaction within the concrete, but we just care about, okay, how it behaves. If the expansion rate is higher than a specific value, then we know, there's going to be some kind of problems, cracks, in the practice. But then for this one, we don't deal with any concrete mixtures. We just put the aggregate powder and the alkaline solution into the tube, and then put it in the oven, let them react, because the reaction is what really matters.
Yeah.
So that's what we are trying to do. And then we will, after like 3 weeks curing, and we will measure the reaction product in the solution, and it will determine like what kind of concentration we have for each element, like alkaline, silica, calcium, and then those 3 elements are really important for the reaction. And then we will measure how much they have after 21 days. And we, in order to measure the concentration in the solution, right now we are using the ICP machines here. So let's put this together. This total different, like a civil engineer will do. So it's more like we are trying to work on the science and to see if we can find a way to solve the problem forever and accurately.
Okay.
So that's why we talk to the local producers, suppliers, and to see what kind of concerns they were having for the previous method. And we, in this way, in this project, we will also compare the result from traditional method and this new method. So after this project, we know how the TFAT works. Because people have more experience for the traditional method, they know how the concrete behaves. But for this one, we don't deal with the beams, concrete blocks. We only give them a number.
Yeah.
But by doing those kind of comparisons, they will know, how this method is going to work in the future. And then we will also prepare a kind of really long list for different aggregates. See if the TFAS can work with all the aggregates here, from coarse aggregate and different reactivity and fine aggregates. By doing that, after the TFAS, we can produce a reliable result just in 21 days. So compared to the traditional way, like 1 year.
Okay, so it gives you a lot quicker results.
Yeah, quicker, and also we want quicker and reliable.
Okay.
That's the goal. We want to do both.
Yeah.
And then, if this method works well, we can provide the state of Louisiana another solid, kind of tool to evaluate aggregate. And after that, this research project will also give us kind of more preparation for the future project. Because the second step is once we evaluate aggregate, there are two options. Get rid of the aggregate, right? Because they are reactive.
Right.
But there's cost. If you don't have good aggregates in the local market, the cost will be high to get good ones. And the other solution is mitigate. But for the mitigation, we also need to evaluate.
Okay.
The traditional method is we just use a specific cement. It's not related to the real mixture design. For this one, in next step, we'll evaluate. Yeah, we use what kind of mixture design you are going to use. We can put the cement you are going to use, all the things together, SEMs, all the things together. We will evaluate the alkaline threshold for this mixture. So we know for this mixture design, what kind of problems you will have.
Yeah.
So based on the evaluation, you can change your design, right? Or you can just, change a different aggregate. So I'm pretty excited because so far we feel like we already got most of the result for some of the coarse aggregate, and then looks like it's going well. So once we finish that, should be good, and we will move on to the alkaline threshold value evaluation. So I think it's going to be really helpful for the supplier and the producers.
Awesome.
Hey, Ricardo, one of the key measures in concrete materials and things y'all are researching is something called surface resistivity. Can you explain to me and our listeners what that measure is and why it's improving or enhancing the quality of the materials used in transportation infrastructure? And then after you've given us a little bit of that background, can you share with us one of the projects you're working on currently to enhance that?
Sure. So surface resistivity is a measurement of how well can concrete receive the passage of electrical charges. So it gives a good insight on durability. Concrete is not a solid block. It is a porous material. So the more these pores are interconnected and bigger, the easier it is for water and other detrimental agents like chlorides to penetrate the concrete, and therefore damaging, causing problems like corrosion. So a higher surface resistivity means that the concrete is denser, therefore more durable.
Okay.
So you're saying electrical, but what was the electrical part?
Electrical charges. So we use a device that passes current through the concrete
To determine
its resistance.
Okay, resistance. That's pretty cool.
That's pretty
So
cool.
the more the concrete resists the electrical charge, the better it is.
Right.
Okay. So as for the project we're studying right now, we're studying the effect of waterproofing admixtures on the surface resistivity of concrete. So right now we're facing a shortage of supplementary cementitious materials such as fly ash or slag. So we want to know if these waterproofing admixtures we're using are potential replacements. So the effect of the reduction in permeability of these admixtures is already known. However, the effect on surface resistivity is still unknown. Therefore, the main goal of this project is to know and to determine how these waterproofing admixtures impact the surface resistivity of concrete.
If you improve surface resistivity, wouldn't that kind of make the concrete smoother?
Yeah, a little bit, because you close the pores.
So is there
if-
like a fine line between too much versus not enough?
Well, actually, the more the better, because you want the less pores that you can get.
Okay.
So, and if you have less pores, of course, it's going to be smoother because there's not little transitions, right? Microscopic transitions.
Zhen, another important measure used to evaluate concrete materials is something called compressive strength. And LTRC recently investigated some new technologies. You mentioned that earlier. You're developing new technologies. Some technologies used to measure compressive strength through non-destructive testing, or NDT. Can you tell us and our listeners about some of these new tools and how they can potentially help Louisiana enhance quality and durability in its concrete materials?
Yes. I think in the past years, the sensor technology developed a lot.
Okay.
And then I think our civil engineers or professors, researchers are also embracing that. And then several companies developed some technology by using the sensors to predicting the strengths of concrete.
Okay.
From sensor data to cloud kind of computation, even AI.
Okay.
Yeah, they combine everything, and then to help our civil engineers to solve those kind of challenging problem. How the strengths develop in like 28 days.
Okay.
Because right now, traditionally, people usually send technicians to the field, cast cylinders, bring them to the lab, and they cure for 7 days, 14 days, or 20 days, depends on your needs. And then break it, you get a compression,
Yeah.
you get a dot. It's not line, right? But with the sensors, you can do the continuous monitoring.
Oh, yeah. Okay.
And then you don't have to send people to the field, right? Because when you do it the traditional way, if you mess up with any steps, like sample preparation or curing or even compression, anything, you are not going to get good result or reliable result. Or even after 28 days or your go date, let's say the strength does not meet the requirement, then you have to send people to the field again.
Yeah.
Right? You have to do the coring, get the samples again, and then do, the compression. So it's really, a lot of effort. But with the sensor technology, we can just install the sensors over there. Depends on the brand. Some of the sensors can last 3 months. You can put the sensors in the concrete for 3 months, and then you can just continuously get the strength data. You just open your computer, log into the portal, you can see the strengths, and then you can make the decision when I need to demote, when I can move to the next step, for the construction.
Yeah.
And if our strengths can meet the requirement in 14 days or 28 days, you can get all the information very easily, and the cost, the efficiency will be totally different.
Since you're able to kind of track it, does it also help with predictions?
Yeah, because eventually concrete is not, the strength may not always increase at the same rate.
Right.
Yeah. So eventually, once you see, it's kind of going to the plateau, the strength, is getting, all of the potential.
Todd saved this one for last because this project has been recognized nationally by AASHTO. That's the American Association of State Highway and Transportation Officials, with a 2025 High Value Research Award. Pretty prestigious. So can y'all tell us about the Miniature Concrete Prism Test, also known as the MCPT, and how it's changing the way concrete materials are vetted here in Louisiana and beyond? And then lastly, why is this work you're doing particularly quote unquote high value?
Yes. Before we talk about MCPT, we can talk about first why we need to evaluate aggregates. I mean, in Louisiana, the environmental everything's different. And then from the previous project experience and the research experience, we have found that there are cracks developed in the concrete before the service life,
Right.
the end of the service life. And then the research showed that there is a reaction, so alkaline silica reaction. It messed up the concrete. So we cannot get, the design, the service life. And how to solve that problem? Right now, the engineers decide, okay, we can just, evaluate aggregate first. See which aggregate is reactive, which one is not. So we can get rid of the reactive ones, and then we just keep using the non-reactive ones. But then even for the evaluation, there are two widely used method right now. The first one is called motor bar test. It's fast, can be done in 2 weeks. I mean, on the time side, it's perfect. But then sometimes it produce, false result. So it means it's not reliable.
Yeah.
So people sometimes start to doubt, okay, I don't want this one. It's give me kind of non-reliable result. So they start to talk about, okay, could you guys do another test? I said, we can do. The other one is CPT, concrete prism test. It's reliable, takes 12 months
Wow.
to produce result. So people said, okay, it's reliable, but takes 1 year. We don't have too much time to wait. When we have a project, ongoing, right? We want to get the aggregate, all the things approved in a short time, right? With this kind of test, we cannot do anything. So they said, can you guys do some research to find out, evaluate the new method, like that's the CPT, MCPT, see if they can be used in Louisiana to help us meet the reliability and also the time frame.
Yeah.
So this project, we finished last year, and the project shows that MCPT was able to identify the reactive aggregates from the rest very effectively. And then we talked to the materials testing group, construction group, and also the local suppliers, producers. They all like it, because this will give the state a new tool to do the routine assessment of the aggregate reactivity, and also give us another, like the local suppliers, the community, another kind of tool to get the reliable result and the quick turnaround. So
How much faster is the MCPT than the concrete prism test? It takes a year.
Yes.
How fast can you get the results with this one?
this one, we can get the result if everything's good in 8 weeks.
Oh, wow. So
So
a
8
lot,
weeks
a lot
compared
quicker.
to 12 months.
Yeah.
Yeah, so much faster, and we can also get the similar reliability.
Okay.
As the one that takes 21 days.
Yeah, because MCPT is based on the CPT. There are several modifications, so we were able to accelerate the test, and provide the reliable result in 8 weeks.
Wow.
Well, is there anything else that each of you would like to share with our listeners? We got listeners from all over the traveling public. Do you want them to know anything else about the work you're doing and how it affects their lives each day?
Well, absolutely. I would love for them to know that the main goal of our work is to serve them. Every mix we do, every test we perform, every idea we explore has a purpose of making their daily lives better.
Yeah.
We want to make stronger, longer lasting, and safer roads and bridges. So every time they travel, whether it's a daily commute, a family trip, or a travel throughout the state, they feel safer and with a greater peace of mind.
Yeah.
And also having an enjoyable ride, a more comfortable ride.
Yeah.
So that's what I like them to know.
I think for me, I would like to, if you guys know any kind of new product or new ideas you want to develop, or that will be good for our civil engineering or like infrastructures, you can contact us and we can discuss, see how we can make all the things happen. We have been doing that a lot of times.
Yeah.
Such as sensor project, we were working with different, development teams from the other states, nationwide or even internationally. Our goals is trying to develop the technology and also the good quality for our infrastructures.
Yeah.
It's not like just for Louisiana. We will share all the results with all the people.
Awesome.
Love it.
Well, thank both of you, Zhen and Ricardo, so much for being our guest on the show today. It's always fascinating to have these conversations and learn more about just the real innovative research being done here at LTRC on a daily basis. Before we go, we do want to have just a little bit of fun with you. We have something called the lightning round. These are just some fun questions that we've prepared. Don't think too hard about these. Just help our listeners get to know you a little bit better. Ricardo, you're going to go first.
Sure.
Garrett's going to ask these questions.
Ricardo, what is the most used or most unusual app on your phone right now?
I would say Google.
Google's
Yeah,
got a bunch of apps. Which one?
Well, perhaps Google Translate.
Oh,
Yeah, it comes handy. Once in a while, whenever having a normal conversation, there's something I don't understand. It's like give me a quick review or
Do you find that it's pretty accurate?
yeah, most of the times I would say like 95% of the times it's, and also the Urban Dictionary. Like there's a lot of not like regular slangs people use here, and they throw me off a little bit, and I have no idea what they meant, so I have to go check my cell phone. Oh, okay, this is what you.
That's so funny.
This is what you meant. Like,
Promise to try not to do that too much. Next question. We know your faith is very important to you. Can you share with us your favorite cathedral that you've ever visited across the world?
well, it's hard to say. I know there's a bunch of beautiful cathedrals, but I think the most beautiful ones are in Rome.
Yeah.
They have the incredible body of the saints. One that I really love was the one in Venice. They have the body of Saint Mark.
Okay.
So, and it's beautiful because by the end of the day, it's what drives a lot of people's lives. There's a bunch of story, there's a bunch of faith and religion, and I think when things go hard, whether it's your personal life or work or any situation, I think your faith is what gets you going, and also the love you have for God, for your neighbor and your family, what gets you going and makes your life sweeter and better, So
That's awesome. Thanks for sharing.
Thanks for sharing. Zhen, if you could meet any person, living or not, who would it be and why?
I think right now what I'm thinking is Steve Jobs. I like him a lot, but it was sad. He passed away. I really like about his strong belief in the product quality.
Yeah.
And then he was also trying to build up the perfect product for the clients, right?
Right.
We engineers need to work hard and find the solutions and then make it happen for our customers. I know it's not easy, but he always would like to put all the innovation ideas, and then combine from design, production, and even app development to make sure you have the best experience. I think that's the thing I really like.
Yeah.
Awesome. We've done International Food Days here. I know y'all have been part of that before. So we also enjoy getting food recommendations from our international guests and people that work here at LTRC. So in that spirit, do you have a favorite dish from home that you'd recommend our listeners try to either cook or find here in the Baton Rouge area?
First, I would say I like Beijing duck, but usually probably it's hard to find in Baton Rouge area.
New Orleans.
Yeah, I know in Houston, sometimes they deliver to Baton Rouge. It's awesome. But then the other things I also like is the Thai food. I think we have several Thai restaurants in Baton Rouge.
Yeah.
Based on my experience, sometimes when I go to those kind of restaurants, I like the different curries. But one of the favorites was the Penang curry. I like it a lot. And then sometimes I will also ask the waiter or waitress over there, I say, could you make some specific, like if I like duck, that day I would say, okay, do you guys have the duck? And then that make it happen. Prepare the duck with this kind of curry. And then usually they will make it happen for you.
Awesome.
Do not just, read the menu.
Yeah.
That's my experience.
Ask them for what you really want.
Yeah. Because they can combine all the things. Because you like the curry and you like the specific ingredient. Talk to them. I have a lot of successful experience.
I'll have to try that.
Yeah.
Well, thanks again to both of you for your time and for everything you shared with us today. Really enjoyed to spend this time with you, learning more about what you do and why it matters. So we're going to take one more quick break before we wrap up today's episode. Well, that's a wrap on episode 24 of The Driving Force, presented by the Louisiana Transportation Research Center. You can learn more about what's happening here at LTRC on a daily basis by visiting us online at ltrc.lsu.edu or on social media through Facebook, X, LinkedIn, and YouTube. We encourage you to like, follow, and subscribe to our channels on each of these platforms. You can also learn more about the concrete research that Zhen, Ricardo, and their entire team are doing by visiting the research section of the LTRC website. You can read project capsules, final reports, tech summaries, and more there. We hope you'll join us next time as we turn our attention back once more to asphalt and welcome Dr. Louis Muhammad. Dr. Muhammad is our longest tenured researcher here at LTRC. We look forward to hearing what he has discovered and what has changed over his 40-plus years of transportation research. So that'll be something to look forward to next time. Until then, we are your hosts, Garrett Wheat and Todd Blunt, and we thank you so much for joining us again today. Drive safely out there.